been a while, so I'm glad to see you back in C110 for DeMoivre's Theorem. So everybody take a second. There's a note-taking guide for you that you should print out at home and help you to follow along with this fantastic lesson. Okay, so DeMoivre, I guess he's some guy in France. He's like, oh, I think I'm going to do some work with some complex numbers because they're so importante. And so he started working with numbers like, -8 minus 5i. And he thought, that is so limiting. What can I do with that number to rewrite it so I can work with it better? Because what I want to do is raise this to certain powers. So maybe I want to take that number and square it, or maybe I want to take that number and cube it. But like this, it would be so hard. Like I could put it in here and then FOIL it out, or put it in here and then multiply it by itself 3 times, but we don't have time to do all that work. So what we want to do first is rewrite this in trig form. So recall, and I'm sure that you guys all love doing this, I'm just going to graph the point -8 on the real axis and -5 on the imaginary axis. And I'm going to think about it as, a triangle in the 3rd quadrant. And all I have to do is figure out this little angle right here. So if you have a calculator handy, which you should all have one at home, I'm just going to do second tan, so let's see, or inverse tan, I guess I should say, of 5/8. So second tan, 5 divided by 8. It looks like I get that this is 32 degrees. But don't write 32 degrees because you have to do something that's going to get you to the 3rd quadrant. So this is really at 180 plus 32, which is 212 degrees. But then we also need to figure out this distance right here. And so that's easy. That's just the Pythagorean theorem. So 8 squared plus 5 squared, square root is 64 plus 25. So I get the square root of 89. So what we want to do is just rewrite this and say this is really the square root of 89 times the cosine of 212 plus the square root of 89i times the sine of 212. But then that's so long, right? We don't like to write all that long stuff out. So we squish this down to that fancy root 89 cosine I sine 212 degrees. So there we are with our first little portion. We've converted it to trig form. So now if I want to take this and raise it to some sort of power, like square it or cube it or do whatever I want to do to it, I can use DeMoivre's theorem. So what DeMoivre's theorem says is if I take any complex number, let's say r cis theta, and I want to raise that to some power, all I have to do is take the radius and raise that to the nth power, and then take the angle and just multiply it by n. Whoa, well, that doesn't seem very hard. So let's see if I can do it with this one. Your paper says that you want to square this number, so that means I want to take that, the square root of 89, I want to square that, and then I want to multiply the angle by 2. So that's pretty easy to do. The square root of 89 squared is just 89. Cis, and then I get, let's see, 2, oh my gosh, no I don't, 424 degrees. But we're going to figure out its coterminal angle and get that 89 cis, what's that, 64 degrees. And so that would be, whatever that is, squared. Now if I wanted to cube it or something, I would just do r cubed and then multiply the angle by 3. And it is really that easy. So let's see. Maybe we have another example that we can do here. Oh man, let's see. If I want to do example number 1 that says z is equal to 5 cis of 220, and I want to find z cubed. Find z cubed. That's the French coming out in me for DeMoivre's theorem. So z we use, remember, to write some complex numbers. Z usually represents a complex number. So all I have to do is cube the 5. So let's see, z cubed would be equal to 5 cubed cis of 220 times 3. Wow, so let's see, z cubed is equal to 125 cis 660 degrees. And then we'll just subtract 360 from this, so I get that z cubed is equal to 125 cis 300 degrees. Dong, dong, dong. Easy peasy, lemon squeezy. All right, now, let's try the second one, because that one, you have to do a little bit of extra work, because you always have to start off writing these things in trig form. So, let's see. I'll start you off. On problem number 2, it's z is equal to 3 minus 4i. So let's see. I'm going to go out 3, and then I'm going to go down 4. 3, negative 4. I know that that guy's equal to 5. And what's this angle in here equal to? Let's see, I got to do this. Inverse tan of 4/3. But I'm not done with that yet. So let's see. So turn my calculator on. So second tan 4/3. You see, I'm not even using a graphing calculator. So I get that this is 53 degrees. Okay, so don't leave your answer like that, because 53 degrees is obviously in the first quadrant. So how do you fix your answer to turn it into something that makes more sense? Well, let's see. I really need to do this. So that would be 360 minus 53 degrees. So when I rewrite this, it would be 5 cis 307 degrees. Okay? And then this one says I want to find z to the 4th. So that means I do 5 to the 4th cis 307 times 4. There you go. I need to go to my calculator. 1220. Oh, I could have done that in my head. Uh-oh. 2625, I think. And now I forgot what the other one was, so now I'm doing it in my head. 1228. But I'm not going to leave that as 1228. I'm going to make sure that I understand where that's going to end up. So I'm going to subtract 360 a couple times. Wow, 3 times. And I get 625 cis, oh, I forgot again, 148 degrees. Okay, so why don't you guys do the next 2, 3 and 4, on your own, and we'll check those tomorrow in class. Now, DeMoivre's theorem is really good for raising numbers to powers, but a lot of times maybe I have something like z cubed equals r cis theta. So in order to solve this problem, I would have to work in reverse. So that would mean that if I wanted to find z, my complex number z, oh, you're so complex with your real and imaginary side. Let's see. Z would be equal to the cubed root of whatever that thing is. Well, it's not really that complicated. Let's say that instead of doing z cubed, I don't even know what power I'm doing. Okay, maybe I want to just make sure that it's going to be z to the n. And then I need to find the nth root. So if I'm working backwards, finding roots, it's exactly the same, but opposite. So z would be equal to r to the 1 over n, because that's like the nth root. Like cube root is 1/3 power, 4th root is 1/4 power. And then instead of multiplying the angle, I divide it. That's it. But oftentimes, like when we were doing trig solutions and stuff, there's going to be more than one answer for these things. So how do you find the other answers? Oh my gosh, this is the only thing that you have to remember. And it's easy. I just take 360 divided by n, and I add it in. So you'll see. I'm going to do an example, and then you'll see that, oh, okay, I remember doing stuff like that before. So here's the back of my paper all the way over here. Hi. Okay. Oh, perfect. Here's an example right here. Oh, and it has all these roots in it. So in case you had a question with the last one on number 4 on your review, let's see. Z cubed is equal to negative 4 root 3 minus 4i. So if I want to solve for z, that means I need to find the cubed root of z. But in order to use DeMoivre's theorem, the first thing that I always have to do is convert it to trig form. Oh my gosh, those roots, they scare me. They scare me. Negative 4 root 3, negative 4. Huh. This looks like something I've seen before, like 1,000 times in geometry. 4 root 3, x root 3, 2x. So I think the hypotenuse is going to be 8. And the side opposite, the smallest, is 30. Oh my gosh, look at me doing all this without a calculator. I'm amazing. DeMoivre would be so impressed. DeMoivre. So that's 180 plus 30. So let's see. I think I could write this as z cubed is equal to 8 cis 210 degrees. Now, the problem's not done. I still need to find the cubed root of this. So z is equal to 8 to the 1/3 cis 210 over 3. So the cubed root of 8 is 2, for those of you that don't remember, cis of 70 degrees. Now, because I'm finding a cubed root, that means I'm going to have 3 solutions. Do you guys see where the 3 came from? I'm going to test you in a little bit. So to find the rest of them, I take 360, I divide it by 3, that's equal to 120, and I just add 120. So one solution would be this. The next solution would be 2 cis 190, and then the last solution would be 2 cis 310. And you can see if I add another 120, I'm going to be out of the 360 range. So let's see what would happen. Let's say, oh, I think there will be more. I will go on forever and ever doing this. I'm going to keep adding 120. So let's see, that would be 430. Oh yeah, but Miss Crumples, she's always freaks out. Make sure this angle is between 0 and 360. So I'm going to minus 360. And what do I get? 2 cis 70. Oh, which is right back to where we started. So these 3 would be your only answers. You don't need to keep going. All right, so let's try one more example, and then you guys can work on the rest on your own. So let's do number 5. So number 5, I have z to the 4th is equal to 81 cis 100. So if I want to find z, how many solutions will I have? Here, I had 3 solutions. Do you know how many I'm going to have here? What? I can't hear you. Oh, here are 4 solutions. Yes, very good. All right, so z is equal to 81 to the 1/4 power times the cis of 100 divided by 4. Okay, so 81 to the 1/4 power is 3, and this is cis of 25 degrees. And then to find the rest of the solutions, all I have to do is 360 divided by 4, which is 90. So there's my first one. Here's my second one, 115. I keep going until I get to 4, 205, And finally, the last one is 3 cis 295 degrees, and those would be your 4 solutions. All right, so why don't you guys finish these last 3, and I will see you in class tomorrow.